Okay, this video is to help us understand completing the square. So the first thing we want to look at is some old factoring um, that we're doing. So on the first one, when I factor, it's going to be x plus 3, x plus 3. Because remember, with the trinomial, you're looking for two numbers that multiply to 9 and add to 6, right? Well, all of these are going to factor in the same way, or where they have the same thing in both parentheses. So we can actually rewrite it as x plus 3 squared. And this part here is part of the vertex form of a parabola. So our goal is to take an equation that is in standard form and move it to vertex form. So remember, vertex form is this. And this part matches that. So these things are called perfect square trinomials. Oh, sorry, I can't talk. And we're going to create these to be able to put it into vertex form. So let's see how it goes. So the first thing you're going to do is you're going to, oops, that's not what we need. Okay. The first thing that we're going to do is we're going to rewrite it grouping the terms with x's together. So I'm going to have x squared plus 8x, and then I'm going to leave a blank, and then I'm going to say plus 12, and then I'm going to leave another blank. So next thing we have to do is figure out what is going to go inside or on these blanks. And the way we figure it out is we take half of this number. So half of 8 is 4, and 4 squared is 16. Now, this is an equation because it's got an equal sign, so we have to keep it balanced. So typically, when we're solving equations, we do the same thing to both sides. But now I need to do the same thing, or I need to balance it out just sticking with the one side. So to balance the positive 16, I need a negative 16. Okay, then if we look at this first part right here, we are going to see how this part here factors. And if we look at it, two numbers that multiply to 16 and add to 8 would be x plus 4, x plus 4. Okay, you're going to start to notice that if I take half of 8, I get 4. It's the same number. Okay, so when I write it in factored form, x plus 4 is really x plus 4 squared, and then 12 and negative 16 would give us negative 4. So my vertex, the opposite of what's with the x and the number at the end, and the axis of symmetry is x equals negative 4. Okay, let's look at the next one. So we have y equals, I'm going to group the x's together, plus blank, plus 5, plus blank. And now I'm going to fill in the blanks. Half of 6 is 3. 3 squared is 9. Since it's on the same side of the equal sign, to balance it out, I need to put it on the other side. So I can't talk. I need to do the opposite sign. So I need to do minus 9. Okay. So now I need to factor the first part. And when that part factors, it's going to factor to x, not plus 3 this time, but x minus 3 times x minus 3. And then we know we've got y equals, we can rewrite this as x minus 3 squared, and then 5 and negative 9 is negative 4. Oh. Okay, so again, your vertex would be 3, negative 4, and your axis of symmetry would be x equals 3. Now let's skip down and try this one where the leading coefficient is not the invisible 1. So on this one, we're going to factor out the 2. But when we try and create these perfect square trinomials, we are only working with the stuff that has an x. So I'm only going to factor the 2 out of that part. So we have y equals 2. And then we have x squared minus 6x plus blank, close your parentheses, plus 23 plus blank. Now we have to fill in the blanks. Okay, half of 6 is 3. 3 squared is 9, so a 9 is going to go here. But your instinct is to put a negative 9 over here, and that's not quite right. It does need to be negative, but I didn't really add a 9. I really added 2 times 9, which is 18. So the opposite of 18 would be negative 18. So now when I write it in vertex form, I get y equals 2. This would factor to x minus 3, x minus 3. So x minus 3 squared, and then plus 5. Now, you don't actually have to write this part out. I'm just showing you so you can see where I'm getting those numbers. All right, let's try one more. Okay, and I'm assuming you can do the vertex and the axis symmetry. I just want you to see the process. So on this one, we have y equals. Now remember, we're trying to make a perfect square trinomial with the stuff that has the x's. So we're only going to factor that -3 out of the two x ones. So then I've got x squared. Since I'm dividing by a -3, it's going to be positive 6x plus blank, close my parentheses, minus 33 plus blank. All right, now we're going to fill in the blanks. Half of 6 is 3. 3 squared is 9. But I didn't add a 9. I added -3 times 9, which is -27. So now in vertex form, I get y equals -3. This factors to x plus 3, so x plus 3 squared. Oh, shoot, I made a mistake. Look what I did. -3 times 9 is -27. So to balance that, I don't want -27, I want positive 27. Sorry about that. And then when I add them together, that gives me -6. All right, let's try two graphing ones on the back, and hopefully this will be enough to give you an idea of what's going on. Number one, this one, the leading coefficient is this invisible ones. We don't have to factor anything out. We just go straight to regrouping and putting in my blanks. So now to fill in the numbers, half of 2 is 1. 1 squared is 1. The opposite of 1 would be -1. So now when I write it in vertex form, I goes y equals, this part factors to x plus 1 times x plus 1, so x plus 1 squared. Notice half of positive 2 is positive 1, not a coincidence. 4 plus -1 is 3. So my vertex is -1, 3. My axis of symmetry is x equals -3. And then when we graph it, -1, 3 is here. It opens up, so we just use our pattern. Over 1, up 1, over 2, up 4. All right, hopefully I didn't mess that up. My glasses are on my desk at school. Okay, next one. Y equals, and remember, we want to create a perfect square trinomial with the x's. So we're only going to factor out that -2 from the x. So I have -2, which gives me positive x squared, and -20 divided by -2 is positive 10x, plus blank, close parentheses, minus 47 plus blank. So to fill in the numbers, half of 10 is 5. 5 squared is 25. But I didn't add 25. I added -2 times 25, which is -50. So over here, I have to add positive 50. So that leaves me y equals -2. This factors to x plus 5, so that's x plus 5 squared, and -4750 is 3. So we get -5, 3. Axis of symmetry equals -5. Okay, -5, 3 is right here. And now our A value, this number in front, is -2. So we're not only reflecting opening down, but we have a vertical stretch as well. So normally we go over 1, down 1, but we have to go over 1, down 2. And normally we go over 2, down 4, but we have to go down 8, which is, I think, about here. Okay, and there is our graph. So that is how we complete the square. So we're changing this equation right here, which is in standard form, and we're completing the square, this process, to get it into vertex form.